Here we are. All right. 6-5, rhombi and squares. Rhombi is just plural for rhombus. That's just plural. So don't think you don't know that word. So we're piggybacking off of what we've talked about already. We've already talked about parallelograms. Opposite sides are congruent and parallel, right? Opposite angles are congruent. Consecutive angles are supplementary. Like all that stuff's still true, right? So then I think the section before this was rectangles. Was it something else or was it just rectangles? I think it was rectangles. So rectangles are parallelograms with 4 right angles, right? So it still had opposite sides congruent, it still had opposite sides parallel, but it had its own rules too. Like the diagonals bisected each other and the diagonals were congruent, right? So these are all special parallelograms that have like their own extra properties on top of the parallelogram properties, okay? So we're going to talk about a rhombus first. The definition of a rhombus is a parallelogram with 4 congruent sides, right? Then the definition of a square is a rhombus, so a parallelogram with 4 congruent sides, with 4 right angles, right? So a square is a super special parallelogram, I guess, okay? And then we have a couple theorems forward and backwards. So theorem 615 says the diagonals of a rhombus are perpendicular. That's new. We haven't had that yet, right? And then theorem 616 says each diagonal of a rhombus bisects a pair of opposite angles. We haven't had that yet, okay? 617 and 18 are just backwards of what we just said. So if the diagonals of a parallelogram are perpendicular, then it is a rhombus. If each diagonal of a parallelogram bisects a pair of opposite angles, then it is a rhombus. That's the exact same thing I just said, but backwards. Okay. 619, if one pair of consecutive sides of a parallelogram are congruent, then it's a rhombus. Let's think about that. If I have a parallelogram and a pair of consecutive sides are congruent, right? A parallelogram by its properties says the opposite sides are congruent as well, right? So this is congruent to this, and then this is congruent to this, but since they're the same, then they're all the same. If all 4 sides are the same, then it's a rhombus. It's only a square if all 4 sides are the same and all 4 angles are right angles. It's got to be both to be a square, okay? So then 620 says if a quadrilateral is both a rectangle and a rhombus, then it's a square, okay? So, let's do this. You guys have the flow chart that I gave you? Let's jump to that, okay? We haven't talked about a trapezoid or a kite yet. I think that's tomorrow probably, but we've talked about this other stuff. So I find that for a lot of people, this kind of helps them keep it on track. So a quadrilateral is just a 4-sided figure. That's it. Right? And then a special quadrilateral is called a parallelogram, where we know that opposite sides are parallel and opposite sides are congruent, and then all the other stuff. So like the diagonals bisect each other, like all that's still true. And then underneath a parallelogram, you have a rectangle or you have a rhombus, right? A rectangle is where you have 4 right angles. A rhombus is where you have 4 congruent sides, and then its baby is a square. It has both. It has 4 right angles and it has 4 congruent sides. So that's what this says. Each shape will have the properties of the one above it. So a square has the same properties as a rhombus. A square has the properties of a rectangle. A square has the properties of a parallelogram. Do you see what I'm saying? A rhombus has the properties of a parallelogram on top of its own, and so on and so forth. Okay? So, is a square a rectangle? Always, sometimes, or never? Is a square a rectangle? It's always, yeah. It's always, because I'm going up, right? Is a rectangle a square? Sometimes, right? So if you're going up, that's an always. If you're going down, that's either a sometimes or a never, depending on the way they say it.
So if you asked if a parallelogram was a square, where would you put?
You would say sometimes. A parallelogram could be a square depending on what information they give you. Right? But a square is a parallelogram. Okay? I know, it's still kind of confusing, but I feel like the flow chart kind of helps some people visually. Okay. They told us quadrilateral ABCD is a rhombus. So I'm going to underline the word rhombus so I don't forget what they just said. So by definition, what makes a rhombus different than the other stuff we've been talking about? What's special about it? All the sides are the same, right? The angles aren't 90, not that we know of, right? Not by definition. So I know that these are all the same. And then I still know, like, opposite sides parallel. Like, I still know all that stuff, too. Okay? So they told me AB is 14, and they want BC. k. What's that?
Equal.
Yeah, they're equal, so 14. Is that okay? That's just by definition of what a rhombus is, right? This time they said AP is 3x minus 1, and they said PC is x plus 9. I don't have anything special about a rhombus with diagonals being bisecting, but I know with parallelograms, diagonals bisect each other, right? So a rhombus is a parallelogram, so these are the same. If you go back, this is the same as this, right? So 3x minus 1 equals x plus 9. Do you guys get that? Even though we didn't say that today on our rhombus rules, we know that a rhombus is a parallelogram, and we know that from like 2 sections ago. Okay? So solve for x. You're going to subtract the x and get 2x. You're going to add the 1 and get 10. So x is 5. Is that what they wanted? No, they want AC, right? How am I going to find AC, the whole diagonal?
You plug it in both and add them together.
You could do that. You could plug it in for AP and PC and add them together. What else could you do? Yeah, you could plug it into 1 and do what with it? Double it, right? Because they're supposed to be the same. You could do it however you want. I prefer to do less math if possible. In my opinion, plugging it into one of them and doubling would be quicker than plugging it into both and adding. But if this was a test, I would maybe plug it into both, because if I don't end up getting the same answer twice, I know I screwed up already, and then I'd go back and fix the problem. Do you see what I'm saying? It doesn't matter how you do it. Okay, so I'm going to plug it into the x plus 9 option. So what is 5 plus 9? 14. And then I have to double it because they're both 14, right? So AC is 28. No matter how you do it, you should get 28. Did I lose anybody? Okay. All right, same picture. ABC, angle ABC is 2x minus 7. And BCD is 2x plus 3. I know they said rhombus, but what is a rhombus also? A parallelogram. What do we know about these are consecutive angles in a parallelogram? They add up to 180, right? Opposite angles in a parallelogram are congruent. Consecutive angles in a parallelogram are supplementary. They add up to 180.
So you put them, okay.
You'd say 2x minus 7 plus 2x plus 3 equals 180. Is that okay? Okay. So I get 4x minus 4 equals 180. And then what?
Add your 4.
Add the 4. So 4x equals 184. Divide by 4.
You get 46.
46 for x. Is that what they wanted?
No.
No. They wanted measure of angle DAB. That's this one. So,
Plug it into C, don't you?
yes. So, I have just one arc on all these. I'm not saying they're congruent. I was labeling this and I was labeling that. But angle DAB is congruent to angle DCB, right? Because they're opposite angles. So, I'm going to plug it into the 2x plus 3 option, right? So, measure of angle DAB equals 2x plus 3. What is 2 times 46? Right, plus 3. 95. So measure of angle DAB is 95. I don't think this is too scary hard. Are you guys okay?
Yeah.
Okay. Anybody still need this page? All right. On this question, it says graph. Okay, great. Let's go ahead and graph it and label everything we have. So you guys have your little graph sheet, right? So -4, -1 is left 4, down 1. Label that J. 1, -1. Label that K. 4, 3. L. -1, 3. M. Make sure you're labeling them. Connect them the best you can. Okay? So it says, given each set of vertices, determine whether parallelogram JKLM is a rectangle, rhombus, and or a square. List all that apply. So, okay, we graphed the thing. If it were a square, what else is it automatically?
Rectangle.
A rectangle and a rhombus, both, right? So if I say square, I better say square, rectangle, and rhombus. Does that make sense? Okay. So we have to start somewhere. So with this, I'm going to just start with seeing if all four angles are right angles. I'm going to check for a rectangle first. Okay. If you look, ML and JK are horizontal lines. If this is a rectangle, meaning 90 degrees at the corners, what would these lines have to be? Straight up and down, vertical, and they're not. So this is not a rectangle. Those are not 90 degrees. You can obviously tell by looking. Sometimes you can't tell by looking though, but if I have a horizontal line, I need a vertical line, and I didn't have that. So there's no way these are 90 degrees. Does that make sense? So because the four corners aren't 90, it's not a rectangle. What is it automatically not also? It's not a square because the four corners weren't 90. It's not an option, right? I think it's probably a rhombus, but I'm going to have to check that, right? So real quick, if these were not horizontal lines, I couldn't do it by just looking, okay? So if there was any slope to this at all, I would have to find the slope. Let's pretend the slope of this was like 1/2. What would the slope of this have to be if it was a rectangle? If this is 1/2, this would have to be perpendicular, which would be opposite reciprocal, -1/2. No, what did I say 1/2 the first time? I'm sorry. If I said 1/2, then -2/1. Sorry, I forgot what I just said. So if you're checking to see if they're a right angle and you can't check by vertical, horizontal, you would have to do opposite flip, right? But obviously on this question we don't. I just want to let you know if you did, okay? So to see if it's a rhombus, what makes something a rhombus? All the sides are congruent, right? So I'm going to go ahead and count ML and JK. That would take like 2 seconds, right? So ML is 1, 2, 3, 4, 5, okay? JK is 1, 2, 3, 4, 5. Well, that's a good start, right? I cannot count MJ and I cannot count LK, right? I can either do the distance formula or what?
Slope.
Not slope. Pythagorean theorem trick. It's almost slope because it's the same concept, but it's not, right? So I think most of you do the trick. Does anybody do the distance formula and you need me to write it down? Okay, so we're going to do the trick. So you make a right triangle, right? How long is this side? 4. How long is this side? 3. So I'm finding JM squared equals 4 squared plus 3 squared, right? I created my own right triangle and I did the Pythagorean theorem. What is 4 squared? 16. 3 squared? 9. So what is 16 plus 9? And I have to square root that, so JM is 5. Okay? LK, I'm going to do the trick again, right? How long is this side? 4. 3. Isn't that the same thing? I'm not going to do that math again, right? This is obviously a 5. So is it a rhombus? Okay. That's it though, right? It's not a rectangle because those corners aren't 90. It's not a square because the corners weren't 90. Did I lose anybody? Okay. So if you want to draw this in your picture, maybe that would help too. You don't have to, but. All right, backside. Parallelogram MNPQ is a square. So they're telling me it's a square. So I still know all the parallelogram properties, but I also know that all 4 corners are 90 and all 4 sides are equal, right? I know all that stuff too, okay? If AP is 3, find each of the following. AQ.
AM is 3.
AM is 3,
It's also going to have to be 3.
Why do I know this is 3?
Because like it's a square, so like it's the same.
So a square is a rectangle, right? It's a special rectangle. If we go back to our rectangle rules, we said that, remember on the rectangle picture, we had that?
Yeah.
So a parallelogram says that these two are the same and these two are the same, but if it's a rectangle, they're all the same because the diagonals are the same. So a square is a rectangle, so all those pieces are the same. Okay. So AQ is 3. Is that okay? Okay. APQ is right here. So I know this whole angle is 90, right? If I go back to my theorems about squares, or maybe not a square, maybe a rectangle or a rhombus, I'm not sure, but let's see here. Something about diagonals. Each diagonal of a rhombus, which a square is a special rhombus, right? Each diagonal of a rhombus bisects a pair of opposite angles, right? So if this angle is 90 and the diagonal bisects it, what is this angle? 45. A square is a special rhombus. They said for rhombi, which is more than one, right, that the diagonals bisect the angles, okay? So if it was 90, it's now 45 for the half that I wanted.
2 sides equal that 90, which is
Say that one more time.
like the 2, it bisects the line, which would split with 90.
Yeah, so MP bisects angle NPQ. So if this whole thing was 90, then this part of it is 45.
So wouldn't the angle by Q be 45 too?
Like this one?
Yeah.
This would be 45, this would be 45, because if they were all 90 and they're all being bisected, then they're all the diagonals made a bunch of 45s.
So can you add 45 together and 45, subtract it from 180, and then get your
This one?
A?
You could. You don't have to, though. I'll show you a property that we don't have to do that, but you could. Okay? So for PM, that's this whole thing. Well, what's that going to be? If each piece is 3, 6, right? For PQ, I don't know, right? That one's not as easy as these other ones, okay? So we're going to use some properties in just a second. So I know that this side is 3, and I know this side is 3, but I don't know this side. What am I hoping this triangle is? What would be kind of nice? If it was a right triangle, that'd be awesome, right? So I'm sure there's a theorem that says that it is. Let's just go find it, okay? The diagonals of a rhombus, because a square is a special rhombus, right? The diagonals of a rhombus are perpendicular. What's that mean? What's perpendicular? It means they make a right angle, right? So is this a right triangle? Yeah. But Paige also pointed out, she said if this is 45 and this is 45, couldn't I find that by subtracting from 180?
Yeah.
Right? You could do that too. You just don't have to because we know it by a property. Okay? So I have a right triangle now with a side of 3, a side of 3, and a side of I don't know. So how do
It
I...
has to be 3.
This one's 3, this one's 3, right? So you're going to say 3 squared, Pythagorean theorem, 3 squared plus 3 squared equals side PQ squared. So what's 3 squared? 9. What's 9 plus 9? 18.
You can't square it.
So this one is where we have to remember old stuff. The square root of 18 we're going to have to break down. We're going to have to simplify a square root. Okay? Never goes away. So there's a perfect square hiding inside of this. What is it? 9 and 2. What is the square root of 9? So 3 root 2 is the best perfect, I totally understand what you're saying answer. Square root of 18 is great, it's just not done. Okay? It's kind of like leaving 2 over 4 instead of making it 1 over 2. It's kind of like that kind of a simplifying. You're supposed to break it down. Did I lose anybody anywhere? Are you sure? Okay. Let me save this and then we will talk about it.